Hello everyone. Today you are assigned to watch the Solving Systems of Equations Algebraically video, and I wanted to add this video on as a little introduction to that video. So if you have the notes for the Solving Systems Algebraically, just go ahead and turn that over and write this information on the back of that page. So before we begin, um, go ahead and write what we know about systems of equations on the back and take a minute to just brainstorm a couple of words that you know relate to systems of equations. Pause the video now and try to write down 3 or 4 words and then go ahead and press play on the video again. So if you've had a chance to go ahead and write some things down, you may have written down that you can solve these by graphing. And this is what we've been working on last week in class, where we graphed 2 lines and we found where they intersect. And that's something else you can write down. The intersection is the solution to the system of equations. So when you have the 2 lines, you graph them. Wherever they touch is where you can find the solution. You also know that sometimes there are no solutions and sometimes there are infinite solutions. All right, so sometimes when there's no solutions, those are parallel lines. If you need a right reminder, go ahead. And when there's infinite solutions, that's when both lines are exactly the same. When you graph them, they're exactly the same and they're on top of each other. All right, so those are some things that you know about systems of equations. The most important thing that I want you to realize is that the solution to a system of equation is, or to systems of equations, is a coordinate, which is written as x, y. So it's a coordinate. It's not just one answer. You will always get 2 numbers, one representing an x and one representing a y, unless of course you have no solutions or infinite solutions. But you'll always get an x and a y. And that's really important to remember before we go into solving systems algebraically. So basically, the reason that we have multiple ways of solving systems of equations is because when you have a system of equation with the numbers that we've been working with in the past, for example, like y equals 3x plus 2, and maybe y equals 1/2 x plus 4, these numbers are small enough that we can work with them and we can graph them successfully and find an answer. But when we move on to more complicated problems, these numbers get bigger and we can't necessarily graph them very easily without having either a giant piece of graph paper. Another thing is we can't graph them very accurately because we may make some errors as we graph with our human capabilities. We might not graph them perfectly. So it's easier to make a mistake or not find the most accurate answer when we're graphing. So that's why there's also a way to solve systems algebraically. And some people have multiple ways of solving systems algebraically. The process that you are going to be watching in the upcoming video is called substitution. And substitution literally means that you'll be substituting part of an equation into the other part of the equation. And what I wanted to show you is just a quick example with this. You'll watch many other examples in the video that you're about to watch, the one that you're assigned to watch, to complete the notes on the other side. But I wanted to just give you one more example, one more quick example before you jump in, and let you see kind of how this all ties together with everything you've been learning. So if I have y equals 3x plus 2 and y equals 1/2 x plus 4, remember this is 1/2, I just can't write it on my computer. If you have these two equations, we could probably graph them and find the solution by finding where the two lines intersect or finding out if they do intersect. You can also use that graphing calculator that we worked with on Friday, and that would also help you determine the solution. However, if you don't have graph paper available or if you don't have a graphing calculator available and you're just really curious to know what this answer is, the answer to this system of equations, you can find out by using substitution. And just like if you had a substitute teacher, it's a teacher who's coming in to replace your original teacher for the day. That's exactly what this is happening with these equations. So if y equals this and y equals that, couldn't you say that this equals that? Now think about it. If you have y equals this, and I'm using this and that intentionally, so if you think about it, if y equals this and y equals that, couldn't you say that since y and y are the same, this must also equal that? It's basically that simple. However, sometimes the y's aren't by themselves, and that's what the other video will get at. So basically, if you're saying that one thing equals y and the other thing equals y, those two things must also equal themselves. So here's what it would look like when you solve it. You would put 3x plus 2 equals 1/2 x. I'm going to change that to 0.5x so it looks a little nicer, plus 4. And do you remember a couple weeks ago we were working with equations that had variables on both sides? Sometimes you needed to distribute or combine like terms, and then you would solve them. I think this is what you had a homework assignment on. You had about 30 questions to solve that had problems just like this. And then you would find out if there was one solution, infinite solutions, or no solutions. That is why we did this. That's why you did that assignment and did so much practice on it, because this is vital for when we solve systems of equations. So one thing I wanted to make sure that you understood before watching that video is that when you put these two pieces of the equations together, you're going to be solving for a variable. And this isn't a trick question, but which variable in here are you going to be solving for? There's only one. You'll be solving for the x. But remember, the one thing we know about systems of equations is that a system of equation is always a coordinate. So it'll always be an x and a y. So let's go ahead and solve this. I'm probably going to have to use my words mostly, so just follow along. But we'll need to, let me make this bigger first. Okay, so first we need to check for distribution. There is no distribution. Then we need to check for combining like terms. There are no like terms to combine on one side of the equation or the other side of the equation. Then we need to get the x, or the variable, onto one or the other side. I always choose the one that has the smaller value to move that one over. This is a positive 0.5, so I'm going to subtract 0.5 from each one. So I'll do minus 0.5x, and on this side I'll do minus 0.5x. And 3 x's take away a half an x, leaves me with 2.5 x's. And I'll bring down the rest that I haven't used, plus 2 equals 4. And then let's see if I can still solve this. I still need to subtract, undo addition and subtraction, so I'll subtract 2 from both sides of the equation. And that leaves me with 2.5x equals 4 take away 2 is 2. And then I need to undo this by dividing by 2.5 to both sides. And I'm going to have some trouble illustrating that. Let's see. Divided by 2.5. So when you do 2 divided by 2.5, if you have a calculator, you can grab it. And 2 divided by 2.5 is going to give you 0.8. So x equals 0.8. Okay, so again, I found what x equals, but remember that the solution is a coordinate. It's an x and a y. Right now, I only have the x. So I have to take this x and somehow find a y. Well, up here in my original problem, they tell me that y equals 3 times x plus 2. So I can take this x and plug it in to this equation and do 3 times 0.8, which is 2.4. 2.4 plus 2 gives me 4.4. So y equals 4.4. So my final solution to this system of equations is 0.8 and 4.4. This right here is my final answer. But if we were to have tried to have graphed these two lines, we probably wouldn't have been able to be this accurate. Remember that these this coordinate right here is the only coordinate that makes both of these equations true. And if you want to, you can check it. Plug them both in and check to make sure that both of these will always be true. And they will. But I just wanted to give you this quick little background information on how to solve what we know about systems already and how to begin to solve them algebraically. The video that's coming up is going to show you a lot more examples and a little bit more of a step-by-step process. And then in class, we'll be doing a journal entry and lots of practice. So don't worry if it's too confusing. I just wanted to kind of give you this background information and then send you on your way. So go ahead and please don't forget to watch the other video to fill in your notes.